Okay, for this video, I'll be going through graphing exercise 2. So again, we are presented with some data in a table. So part A, identify any errors in the table. So if I look at this, now most commonly used instrument or apparatus for measuring length is either the meter rule, which actually has a precision of 0.1 cm, okay, because this is on cm, right? And the next one is actually a digital caliper. Okay, so all this you need to memorize. The precision is 0.01 cm. Then something that's more precise is your digital screw gauge, okay, or micrometer screw gauge. The precision is 0.001 cm. So what is 0.1 cm in meters? It is 0.001 meters. Okay. What is it in mm? It is it's 1 mm. Okay. So you have to actually memorize all this precision, especially so for precision of digital caliper and micrometer digital screw gauge. Okay, so now if I were to look at this, it seems to be measured with a meter rule because cannot be 40 cm. I use a digital caliper or digital micrometer screw gauge. It's just not possible. And because the precision of the meter rule is 0.1 cm, the precision is okay in this column, so nothing is wrong. So next we move on to the next column. Is actually I1. I1 is actually your current, right? So it's always the physics quantity followed by slash and then the units, which is ampere, right? So there's some error here. Basically, there shouldn't be any units in the table, right? Because it's already presented very neatly in the heading. And then I look at the precision, it's 0.35, 0.30. It seems very consistent, so it is okay. Now we look at I2. Okay, over here there's no units in the data row or data table because it's already in the heading. But I do have this error. It should be 0.30 just to be consistent. I'll elaborate more on the precision of the voltmeter and ammeter sometime later. Okay, now this is IA, so I take it that this is the average of I1 and I2. So average always follow precision. Okay, average follows precision of the instrument. Okay, so 0.35, so this should be 0.30. Now this cannot be 0.265. It will need to follow the precision. That means it's 0.27. This is okay, this is okay, this is okay, right? Now all these are actually the raw data, right? Raw data meaning you actually measured, you gotten it from measurement. Okay, if we look at the last column, it is 1 over IA. That means 1 over the average of the current, right? Maybe they need us to do something about it, to do the inverse of the average of the current. And one error is that all should have units. So here will be slash, this is the physics quantity, is 1 over IA. The units is 1 over A. Do you follow? Because the unit for average of current is ampere. Therefore, 1 over IA, the unit should be 1 over ampere. Okay, 1 over ampere. Right. So this is actually not true measurement. This is actually true calculation, isn't it? So for calculation, you actually need to follow certain rules, and because this is division and multiplication, we need to follow the rules of least SF for multiplication or division. Okay, now what about subtraction and addition? You follow least DP. Okay, now this 1 over IA, this one is not a raw data. It is a constant, a number one. So we don't care whether is it 1SF, 2SF or 3SF. We don't care about it. Rather, we need to look at the IA. So in this case, this is 0.35. The first data is 0.35, and that is itself a 2SF if I'm considering it. Therefore, this should be 2.9. Okay, if you take your calculator, you take 1 divided by 0.35, you will get 2.86 blah 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 blah. But remember, we need to follow the least SF of the raw data, which is 0.35, which is 2SF. So you should correct it to 2.9. Okay, and of course this 3.333 is the recurring number, so we can't do that. And please don't put this 3.3 with a dot on top. We don't need that. It is just 3.3. Then this will be 3.8. This is 4.5. Okay, do your calculation. And this is 4.8, and this should be 5.0. Right? Because the raw data we are using for this division is actually 2SF. So 1 divided by 0.2 shown on your calculator is 5, but you still need to follow the least SF rule, which is 2SF. So you need to add a 5.0. Okay, so this is very important, especially for the pure physics students. Okay, so now that we are done with this, okay, it's a bit messy. They want us to plot a graph of I1 over IA against X. Okay, so this will be my X-axis, and this will be my Y-axis, right? Y against X, right? So this will usually be the independent variable, and this will be the dependent variable. You see how nicely the intervals go, which we can plan, right? The X we can plan. The one that's dependent on it, it wouldn't have such a nice interval. Okay, so this will be our Y-axis. Okay, I will not be maybe I do the scale for y'all. Okay, so how do we get the 4 points? Still remember your ASPL, which stands for axis, scale, points, and then your best fit line, right? So your axis, very easy. Just label your X and Y with the physics quantity / units. Okay, I forgot. So this is 1 over IA, right? /1/A. So this is a physics quantity, right? And we need a /, we don't use brackets, followed by the units. Okay? The x-axis is a bit simpler. It's X/cm. Alright, so with this, you'll get your 1 mark. Now let's look at the scale. Okay, so the minimum value for X is 15, maximum is 40. And remember, you do not need to start from 0 unless the question says so. So I need to see how many squares I have in the X direction. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 squares, and I need to cover more than 50% in the X direction. That means I need to, like the previous video, cover at least 5 squares. So actually I can start from 15, 20, 25, 30, 35, 40, 45, and maybe throw in a 50. So with that, do I actually cover everyone? So 15 to 40. So this is 1 square, 2 square, 3 square, 4 square, 5 square, right? So I will have points in these 5 squares, and 5 out of 9 is actually more than 50%. So this one is okay. Okay. Then how about for the y-axis? Y-axis, the minimum value is 2.9. Minimum value 2.9, maximum value is 5. Okay, so using this slash, I can actually divide it into the X scale and the Y scale. Okay, so they don't have to start from the same value. But do remember to have the slash, right? So the minimum value is 2.9, right? So maybe I do a 2.8. So if I do 2.8, then so this will require some practice, and you need to actually count it properly. So even for me, I still need to plan like 2.8. Then if I do 3, okay, 3.2, 3.4, 3.6, 3.8, 4, 4.2, 4.4, 4.6, 4.8, and then 5. Oh, just nice. Okay, so by doing multiples of 2, I can actually cover the whole range. If I start from 2.8, then with every interval of 0.2, I can fit in my graph very nicely. Okay, 3.6, 3.8, 4.0, 4.2, 4.4, 4.6, 4.8, 5.0, right? So everything will be covered. So next thing, once the scale is determined very nicely, you'll get that 1 mark, followed by the points, which is always x comma y. Now, very important. So sometimes I will like highlight this, I will highlight this, and then with this, I will say that this is actually my y, right? And this will be my x. So there won't be any problem. But you all say, oh, the values actually differ by a lot, because there's 15 to 40 for the x and 2.9 to 5 for the y. But sometimes you may get similar values. Then there will be cases whereby student will plot the points incorrectly. Now, I think for O-level, they will actually allow 1 point to be plotted wrongly. But if you have more than 1 point plotted wrongly, then you will not get the points mark. And the point mark is actually easy to get, just like the axis. Okay. Lastly, we have the line, which is the best fit line. So I have already shown how to draw a best fit line in the previous video, so please watch it. And you can actually, for best fit line, you will require some kind of practice lah. Okay, then calculate the gradient. So basically, once I have drawn the best fit line, okay, you need to choose 2 points that are far apart so that the gradient triangle is more than 50% of the line, and you need to do your x comma y, x comma y. Okay, so once you have calculated your gradient, you show clearly, then they will ask you to determine the value of this 1 over IA, which is the y-axis, where your graph crosses the y-axis. Against hence or otherwise, that means if you started from 0, then you can just read it off. But in this case, we didn't start from 0 for the x-axis. So therefore, using the gradient that we have calculated, use our y equals mx plus c. And then, since we have calculated gradient, we can substitute our gradient triangle coordinates, either one set. Okay, throw it in, and we can calculate for our c. Now, take note, if let's say you draw a best fit line, and let's say some points are here, right? Like that, like that. Okay, and you see that actually this point is either very near to the point or not. You can't really determine. So I would suggest you don't use this point, your data point. Choose a new coordinate to be your x and y coordinate, because when you are drawing your best fit line, this point may or may not, it may look very near to be on the line, but it may not even be on the line itself, right? So I would need you all to choose another point, and it's not difficult. Okay, so in summary, try not to use the data points. Try not to use the data points as a set of coordinates. Okay, example, try not to use 40.0, comma 2.86. Okay, because it may not even appear on the line, even though it seems like it's on the line. Okay, so once you have that, I think this exercise should be okay.